Alright, this is a very nice integral that I like to share with all my friends who are starting off their techniques of integration, learning the various techniques to integration and how fun they are. So this is an integral that is the integral of arctan of x dx, and of course arctan of x is the same as tan inverse of x. They're the exact same thing. And so really, people often look at this and they don't know where to start. But really, you're just overthinking it. It's just a simple IBP, integration by parts. So now you're probably like, hey, are you lying to me? Like, where's the u and the dv in this? All I see is an arctan of x. Well, we kind of have to rewrite this here, and well, we know that arctan of x, right, is the same as arctan of x times 1. So we're going to rewrite our integrand here as arctan of x times 1 and then dx. And so we see here, then our u will just be arctan of x. And hopefully you know what the derivative of arctan of x is. And then dv is just going to be 1 and then dx. And so now, remember that this is the same as uv minus the integral of v du. And so if we look at u here, that's arctan of x. If we want to find du is just the derivative of arctan of x, which is just 1 over 1 plus x squared, and then we have a dx here. And then, of course, if we want to find v is just the integral of 1 dx, and that's just going to be x. Okay, and so now if we look at this here, it's just simple. What is our u? It's arctan of x. What is our v? It's just x. I'm going to write parentheses here, just to not make any confusion that this x is not in the argument of arctan of x. And then minus the integral of v is x, and then times du, which is 1 over 1 plus x squared dx. And so now, hopefully you see with this integral, it's just a simple u substitution. I'm going to rewrite this as x over x plus x squared, or 1 plus x squared dx. Okay, and so not to get confused with this u, I'm going to do a w substitution. I'm just going to use a different variable here just to know that this u that I'm going to use in here is not the same as this u. So I'm going to let w, and then hopefully you see that we just let this equal to 1 plus x squared, and dw is just 2x dx. And so if we do the substitution here, we get arctan of x, or I'm going to write it as x arctan of x, minus the integral, and then we have x over w times, and then of course dx is the same as dw over 2x, so then we have dx here, which is dw over 2x. And so then these will cancel, these x's will cancel here. I'm going to write these a little bit away here, right? I set w equal 1 plus x squared. dw is just 2x dx, and so then dx is just dw over 2x. So this is how I have x here over w, because remember w is just 1 plus x squared, and then that times dx, which is dx is just dw over 2x, because dw is 2x dx. I isolated dx by saying that equal to 2w over 2x. Then we see here that the x is canceled, so then now we have x arctan of x minus the integral of, 1/2 integral of 1 over w dw. And hopefully you know this form. That's just going to be ln absolute value of w. So this is going to be x arctan of x minus 1/2 ln absolute value of w, and then that plus our constant of integration, since it's an indefinite integral, plus c. And so now with w, what is w equal to? W equals to 1 plus x squared. So then therefore we'll just have x arctan of x minus 1/2 ln absolute value 1 plus x squared plus c. So I want to write down, right, this integral right here is equal to, again, the integral of arctan of x is just x arctan of x minus 1 half ln absolute value of 1 plus x squared plus c. If you're really not confident, just take the derivative of this, and that should equal the arctan of x. So yeah, this is really not hard as long as you just kind of do some simple manipulation, right? You were confused at first, right? Arctan of x, obviously, it's just arctan of x times 1 is the same as arctan of x. And then we go from there. So that's my advice when solving integrals like this. And then if you then this strategy doesn't work, then you're going to have to do another technique. And then if those techniques don't work, then your teacher gave you an impossible question, and then you're going to have to use some error function. Oh, so, no. You'll be fine. I'm sure you won't get integrals that are more hard than this kind of stuff. Alright? See you guys in the next one.